Assalamu alaikum. Myself Dr. Shahab, and I welcome you into chemistry lecture. Um, in previous lessons, we have seen various classification of the element, various types, and how the elements are classified earlier. And we have seen the various trends in the modern periodic table, out of which we have seen the valency. Okay, so valency is a element, it is a element's ability to combine with the other elements, and it is determined by the number of electrons or number of valence electrons present in the atom, or number of electrons present in the outermost shell of an atom. So we have seen the valency. Along the period, the valency goes on increasing or decreasing, and likewise we have seen second trend in modern periodic table. We have seen the atomic size. The atomic size is the distance between the atom's nucleus and the outermost shell is a atomic radius, and this atomic radius basically determine the atomic size. Larger the radius, larger will be the size of an atom. So we have seen the in a particular period, in if we go from left to right along the period, we have seen the only electrons get added in the particular shell, not the shells get added. Means if we are considering a second period, in second period, by moving from left to right, we have seen the at in group 1 there is one electron, in group 2 in the same shell there is two electron, in group 3 in the same shell there is three electrons. Likewise, the electrons are getting added in the same shell along the period, due to which what happened, at the time of electrons are getting added in the same shell, the same times number of protons also get increases. These number of protons correspond to the positive charge on the electron. This positive charge on the atom. This positive charge of an atom attracts the negative electrons toward the center. Due to this, the size of an atom get decreases along the period. So the size of an atom or atomic radius get reduced along the period. In each period, the atomic size get reduced. So there is a decreasing atomic radius along the period. This character we have seen, this trend we have seen. Okay, and along this group, means from above downward, the new shells get added in each group. Due to this, what happened, from above downward, from top to bottom, the size of an atom get increased. Due to this increased in the size of an atom, what happened, the atomic radius is also increased. Okay, because new shell is added, so atomic size from top to bottom in a particular group is increases. Okay, so atomic radius is increases from above downward, and atomic radius decreases from left to right. That is what we have seen earlier. Now I want to take to the new next topic, and after that topic our lesson will over, uh, that is periodic classification of element. So what is that topic? That topic is metallic and non-metallic character. So basically, what is the metallic character and what is a non-metallic character, we will see it. Okay, so what we have seen, that it is also called as electropositivity and electronegativity. So what is that? The metals are having a let me navigate you to that metallic character and not metallic character. So we have seen the So what we have seen that there are three basic types of elements, that is metals, non-metals, and metalloids. So what are the characteristics of the metal that we have learned in our previous classes? That the metals are typically solid, shiny, and they have usually they are having a high melting point, and they conduct the electricity, and they conduct the heat. And we have seen that they are having a special ability. They want to lose the electron to form a cations. Okay, that is the ability of metals. So you have to write it down if you are taking notes. What is that point? Metals are having ability to lose the electron. They want to lose the electron to form. If they lose the electron, they form cation. And in the previous classes I have shown cation is having a positive charge. So sodium is a metal and it loses the electron, it becomes Na plus. So Na plus is what? Cation. So metals are having the ability to lose the electron. Okay, they have tendency to lose the electron. From where they lose the electron? They lose the electron from their valence shell. From where? Valence shell. And the name of that electron that is present in the valence shell is called as valence electron. So usually metals ability to lose the electron from their valence shell, or to lose the valence electron to form a cation, is called as electropositivity. I repeat it. Metals' ability or tendency to lose the valence electron to form a cation is called as electropositivity. It's called as electropositivity. In on other hand, non-metals have a tendency to accept the electron in their valence shell to form an anion, and it is called as electronegativity. It is called as electronegativity. On other hand, nonmetals have a tendency to accept the electrons in their valence shell to form an anion, is called as electronegativity. This is called as electronegativity. So basically, what is the all this phenomenon? I just want to take you to one concept over here. I will try to find some place. So this is a place. Okay. So what is electropositivity and what is electronegativity? What is cation? What is anion? And what is the noble gas stable electronic configuration? All these things what we will go one by one. Okay. So basically this is a nucleus of an atom, and this nucleus of an atom is having two things: neutrons and protons. See, these are neutrons and protons. See, this is protons. Okay. And this neutron carries no charge, but the protons carries positive charge. So this particular atom is having two positive charge. Okay. Same is the thing is that the next thing, the electrons are revolving in the orbit. So suppose this is having two electrons, that is having a negative charge. So these two positive charge attract these two electrons. Okay, and this is a very attractive force from the nucleus, from the basically protons, to attract the electrons towards its center. This force is called as nuclear force of attraction. This force is called as nuclear force of attraction. What is nuclear force of attraction? It is a force exerted by protons on the electrons to attract themselves toward the nucleus. Okay, what is the nucleus force? What is the nuclear force of attraction? It is a force exerted by protons on the electrons to attract or held the electrons together in the particular atoms. That is a nuclear force of attraction. The concept is clear. So electron of any element is held by this attractive force. Electron, this attractive force is holding the electrons that is having a negative, this attractive force, okay, exerted by the protons that is having a plus charge. So what is the case in the metals? So metals, they are having a tendency to lose the electrons. So what is that? So basically in uh, metals, there are two or three points. number one is Number one point is, metals usually they have less number of valence electron, usually 1 to 3. They are usually having a very less number of valence electron, 1 to 3. Okay, so for example, if we take the example of sodium is having only one valence electron. Okay, second point is, usually the effective attractive force, what is this as effective nuclear attractive force, is very less on this less on valence electron in metals, in metals. This, there are two things. Okay, just try to remember all these things. There is very less number of valence electron. First thing, in metals, what we are speaking over here is, we are speaking in case of metals. Okay, metals, what is that? Very less number of valence electron, only 1 to 3 in their valence shell. Second thing is that nuclear attractive force is very less. That two things, this nuclear attractive force on valence electron is very less. Due to this two combined effect, due to this combined effect, what happened? Due to this combined effect, metals have tendency to lose the electron, and they want to attain the stable noble gas configuration. They want to attend, they want to have the stable noble gas configuration. What is the noble gas configuration? Noble gas configuration is that they are having their complete octet. Noble gas is having the 8 electron in their last shell. So metals usually they want to have a 8 electron or stable noble gas configuration. So this tendency to lose the electron is called as electropositivity. So it is called as electropositivity. So what is happening in the our periodic table? Down the group, in every period from above downward, new shell is added, due to which the increase in the distance between nucleus and valence electron is resulted. Okay, new shell is added at every period. That's why the distance between nucleus and the last electron get increased. Due to what? Due to this, what happened? The distance is increased, means less nuclear force of attraction is exerted on last electron. Due to less force of attraction on that, and they are also having only 1 to 3 valence electron, due to which they are easily losing their electrons, and by losing their electrons they get the stable noble gas configuration. Okay, and they, by losing the electron, they are attending a noble gas configuration. This is called as electropositivity. So from above downward, in each group, electropositivity get increases. Okay, this is called as metallic character. Metallic character from above downward during the group get increases. Reverse is a true also. Non-metallic character, what is this non-metallic character or electronegativity? Non-metallic character or electronegativity is when the electrons get when the element want to accept the electron and form an anion, is called as electronegativity. And non-metallic character. So if we see if we see there is I will take you to the some slide over here. The thing what we have discussed is there is what we have discussed is increasing this point. Okay, increasing in electropositivity and non-metallic character, because in each shell on one shell is added at every time. Here the three shells, so electropositivity is increases. Reverse is true, the electronegativity is increases and non-metallic character increases along the period. Okay, river and also decrease in electropositivity and metallic character, this is also true. What happen, see, along the period, what happen if this is a second period, it is having only two shells, and in each group one electron is added at each time. So here is one electron, here it become two, here it become three, here it become four. In the same shell the four electrons is occupied, due to which the attractive force of nucleus becomes strong and attractive. Due to attraction they are not ready to lose the electron. So they are not ready to lose the electron means they are ready to accept the electron. So what is the ability to accept the electron is non-metallic character and electronegativity. So there is an increase in electronegativity and non-metallic character. The last thing that we will have to consider over here is gradation of halogen family. What is this gradation of halogen family? Basically the 17 group that contain the members, the 17 group of periodic table, that is called as halogen family. They are all having a general formula x2. Okay, a gradation is observed in these states of this group, that fluorine and chlorine are in a form of gaseous, and bromine is liquid, while the iodine is solid. Means they are this 17 group of periodic table. It is showing the three states of matter, that is liquid, gaseous, and solid. Okay, these three states are present in this particular group, that is called as gradation of halogen family. So with this lesson is over, and you have to do the homework in your register. You have to do the exercise. If you are having any doubt, I will try to solve that doubt in the live session, and after that live session and all doubts are get cleared, then we will have a assessment on this lesson, inshallah. And if you are not getting anything, you can directly ask me on my WhatsApp number, or you can call me anytime, or you can ask me the doubts in my personal window on WhatsApp. And another thing is, you can ask me that doubts in live doubt clearing session, that inshallah I will held I will notify you the time, and after that doubt session is over, we will conduct a assessment on this lesson, inshallah. Thank you.